All right, so welcome. We have 3 points here, and we're supposed to be constructing an equation of a circle, or at least as many equations of a circle as we can. And we have a certain constraints here. So one of the constraints is that one of the points is supposed to be the center of the circle. We have another constraint which says that one of the points is supposed to be on the circle. And then the last constraint that we have is that a point is inside of the circle. So that's what we're supposed to construct. So if you could imagine, if you had a circle, and I'm going to draw just a basic circle here, and what that would mean is we would have one of the points which is obviously its center, so that's 1. We would have one of the points which is somewhere on the circle, and then we have one of the points which might be somewhere inside. That's what we want to be able to construct just from these particular points. How would we do that? Well, if you can see this particular circle, now these points are not scattered anywhere yet. I'm going to plot them in just a second. If you look at this, what do we know about circles? Well, we know that if this is its center, this is x1, y1. So let's say if this is the center, and I can just call this maybe xc and yc for the center. And this particular point is on the circle. So that means that this line segment, the length of it would have to be its radius. Our equation of the circle would simply be x minus xc squared plus y minus yc squared is equal to the radius squared. That's what the actual equation of a circle would be. Now, because we know what the point, or at least what the 3 points are, one of those points is going to be our center, and one of the points is going to be lying on the actual circle, and then one is going to be just kind of lonely inside of the circle right there. Well, can I find the radius of the circle that I need if I have all the points? Well, I certainly can find out what the length of each line segment is between all of the different circles. And then I can try to see and I can gauge, okay, so which one is going to actually work for me. So let's try to do that. So here are my points. I'm going to remove this and come back to that after. And if you've forgotten how to calculate the length of a line segment, I'll put up a link up above there for you if you want to. And I'm going to kind of calculate the line segments between each of those points, and I'll do it in fast forward fashion. So here are the lengths of the line segments between them. Now, let's not forget, okay, so I can of course go in reverse. So instead of going from, let's say 2, 2 to -3 and -1, I can go in reverse, but the line segment is going to have the same length. So if that was the radius, it's still going to be the same. Now the same thing can happen between 2, 2 and 0 and -4. So the only thing that is missing, let's try to calculate still the line segment between -3, -1, and then 0 and -4, and see what that would be. And that's going to give us all the different line segments that we would have, and we can almost kind of create a triangle in between them. All right, so let me do that in fast forward fashion. So that's the last one. So we basically now have all the lengths between the points. And here, let me just show you. So here are the points. I've plotted them up. You can see them there on the screen, and I'm using Desmos, which is an amazing tool, and hopefully still free when you're watching it so that you can use it to plot things out. This is what we basically have constructed. And now if I would take this, I'm going to kind of take a screenshot of it. That's what we have. And what we've created is we basically know now what these lengths are. So we know this length, we know that length, and then we know this length. So clearly now that if I draw this out, it looks like that definitely this particular line is going to be the smallest line, right? And we could tell by just simply calculating because it was the square root of 18. So this was square root of 18. Now between 2, 2 and 0, negative 4, that was square root of 40. So it looks kind of deceiving. Then we have square root of 34 on this particular line. Those are all the lines that we have. Now, okay, so how are we going to construct a circle? Well, notice that if we tried to construct a circle such that we took this point, which is going to be negative 3 and negative 1, or we took this point, which is going to be 0 and negative 4, and used this as a radius right there, then we would run into trouble because of the fact that we wouldn't be able to contain this point within that circle. Because our circle would basically be, so if we would draw it out, so let me try to, okay, so put this circle in here, and notice that we would have to make it much, much bigger, and kind of shift it along, so that it is going through this point, and that is the center, so it would look something like that. But that point 2, 2 would have been outside of the circle. So we know that we can exclude this particular square root of 18 as a radius for one of those circles. Now, however, if we take the circle and now we shift it around, okay, notice that in here, if I take that, now it's going to be a lot bigger because I am taking, for instance, this as my center. This right here would have been my center of the circle. And now I would take this as my radius. Now this circle, and we're going to plot it out so that you can actually see it, you'll see that clearly it's going to contain this on the inside. It's going to have this as its center. So that satisfies the rules. The rules state that we have to have one point as the center, one point on the circle, and then one point inside of the circle. So let's construct this. So our equation would have been x minus, now notice this was the point 2, 2, so I'm taking that as my center. This would have been y minus 2 squared is equal to, and now it is the square root of 40 squared. So if you square the square root of 40, so this is going to be just 40. So if I take this and I'm going to now plot it out, I just want to show you what will happen so that you can visually see this. I'm going to put this circle in here. So x minus 2, this is going to be squared, plus y minus 2, and this is going to be squared, is equal to 40. And notice, so here I'm going to zoom in on this circle, and you can see now that, all right, so 2, 2 is our center. 0, negative 4 is on the circle, which is what we wanted it. And then negative 3, negative 1 is inside of the circle. So that's one of the circles that we could have. Now, is there another circle that we can construct? Because the question said, construct as many as you can. Well, we definitely know that we cannot use, if I go back here, we cannot use the square root of 18 as our radius and negative 3 and negative 1 or 0 and negative 4 as our centers, because it would not include that point 2, 2. It would be too small of a circle. So, and we can try it, you know, and I can show you what happens. And if you take this, so if I construct another circle, so this one will not work, so it would have been x, I'm going to take, let's say, negative 3 and negative 1 as my center. So that's going to be plus 3 squared, plus, this is going to be 1 plus 1 squared is equal to the square root of 18, which is my radius. So that's going to be squared, so it's going to just be 18 now. If I put this in here, and notice that, okay, so it's a great circle that we have here. We certainly have the point 0, -4 on that circle, which is the green one. But the point 22 is outside of the circle, so this will not work. And you would run into the same problem if you would put 0, -4 as your center and still keep the same radius. So it would just simply shift the circle down around the center, but it would still exclude the point 22. So now the only other one that we can create a circle out of is, instead of having 22 as your center, which is the blue circle that you see here, okay, we swap it, meaning that we're going to take the same radius, which is going to be the square root of 40, but we're going to put the center around 0, -4. And you'll see, if I take this, and I simply just now, instead, my center, so it's going to be x, okay, so now it's going to be 0, all right? You don't have to put that in there because it's x minus 0 is obviously just x, plus now your y, so notice it's minus -4, so it's going to turn that to 4. This is going to be squared, is equal to, and we're going to keep the same distance for the radius, which is the square root of 40. So square root of 40 squared is just 40. And notice, so what we've done is we've taken the blue circle and we shifted it around. And here, this circle also works because it has now the point 22 on the circle. The center is 0, -4, and the point -3, -1 is inside of the circle. So we could construct only 2 circles maximum that we would have this actually happening. So this is a great exercise for anybody who wants to learn line segments, figure out radius and understand and have a good understanding of how these circles and what their equations actually look like. And definitely use Desmos as a tool to help you. So thank you for watching, and we'll see you in a future video. Bye, everybody.